Hello everyone, welcome to Data Science Simple. My name is Sebastian. Today we'll be talking about random forest and decision tree classifiers. But before we do so, remember to like this video, subscribe to the channel, also clone the Data Science Simple repo so you can get the notebook. So I'm gonna show you how to set up the random forest and the decision tree classifier. I'm gonna show you how to train it. I'm gonna show you how to obtain predictions and probabilities, and then I'm gonna show you how a single decision tree is created and what type of information you can find in it. So let's jump into the notebook. Alright, so we're gonna start by importing a bunch of stuff. First, random forest classifier, then decision tree classifier, and then here make classification. This is a function that is going to allow us to create fake data, and it's going to be super useful. Then finally, here I'm going to import a bunch of stuff that we're going to use to create a visual representation of our tree. We're going to start by creating our data, our fake data. So we will create two lists, one called features, the other one called targets, using the make classification function. And this function takes some arguments. The first one is n samples, and we're going to make that equal to 1000. This is telling Python that we want 1000 observations. Then we tell Python that we want 2 classes and 6 features. This final argument right here is just a seed that ensures that every time I run the notebook, I get the same data. All right, now let's look at the features and the targets. As you can see, I'm printing the first 2 features and targets, and the features are just a list of 6 elements. They are real numbers. And the targets are either zeros or 1. Now here in this cell, we're going to split into training and testing. Training are going to be the first 800 elements, and testing the last 200 elements. Now the fun part, that is creating the classifier. So we're going to create the classifier here in this line, and we're going to call it rf_clf, random forest classifier. And we create it using the random forest classifier function, and we pass some arguments. The first argument that we pass is n estimators equals to 10. This is the number of trees in our random forest. I think the default is 100. Now max depth equal to none. This is how deep our trees are going to be. So here we're telling Python just make the tree as deep as it needs to be. Then we're saying min samples split equals to 2. This is the minimum samples required to split a node. So we're setting that to 2, and I think that's the default as well. And then min sample leaf equals to 1, and that it means the minimum number of samples required to become a leaf. We're going to set that to 1. I think that's also the default. And now I'm going to add a couple of things, and the first one is criterion. I'm going to make that equals to Gini. And this Gini criterion just gives you a measure of the quality of the split. We will talk about it later. Finally, we're going to set max features equal to Auro. This means that the number of features considered in each one of the split is going to be equal to the root square of the total features that you have in your model. Finally, we're going to train the classifier using the fit method. Now we're in the position of obtaining some predictions and probabilities using our classifier. So that's going to happen here. As you can see, we're creating a couple of lists, and we're using the predict and the predict proba methods. And what we're doing is passing the test set, the features in the test set. So I'm going to run this cell, and now in this cell right here, I'm going to print the first 10 predictions and the corresponding targets or the ground truth. As you can see, it fails 2 times. Now let's look at the probabilities. I'm going to print the first 10 probabilities. As you can see, this is just a list of lists where In each one of the elements, we have the probability for the observation to belong to the class that we're calling 0, and the second element gives you the probability for the observation to belong to the class that we're calling 1. And look, that is interesting that in the two cases where it predicts the wrong class, the probabilities of belonging to the class 0 and 1 were very close. Alright, so now we're going to move to single decision trees. The idea is that we're going to train a single tree and then we're going to compare it to the random forest. So let's start by creating our tree here using the decision tree classifier. And we're going to pass max depth equal to none, mean samples equal to 2, and mean sample leave equal to 1. So pretty much we're leaving everything to the default values. Then the training takes place here using the fit method. So let's run this cell. Now, predictions and probabilities. They are obtained in exactly the same way using the predict and predict proba methods. So I'm gonna get those here, and here I'm gonna print them to a screen, the first 10. As you can see, the decision tree failed 1, 2, 3 times. Now, I'm not gonna print the probabilities again because it's gonna be exactly the same as what I showed you before, and I really want to show you the visualization of the tree. So let's start with that. So what we're going to do is we're going to create a new classifier, a decision tree, and we're going to set the depth of the tree to 3. That's because it will be easier to visualize. So we create it in this line, we train it in this line. Now, this block of code is going to print to a screen a visual representation of the tree. Let's take a look. Alright, so we have our tree, and as you can see, this one is the root node, and these ones here are the leaves. In computer science, trees are upside down. Now, let's look at the information that we have in each one of the nodes. For example, let's look at this one. Here we have the first piece of information says feature for less or equals than minus 0.4. That's a question. If the observation passing through this node indeed has feature 4 less or equal than 0.4, it will move towards the left, towards this node. Otherwise, it will move down towards this node right here. Now, Gini equal to 0.21. Gini is nothing more than a metric on how pure your node is. The closer to 0, the more pure your node is. Samples, we have 408. That means that when this node was constructed, we had 408 samples. Then we have value equal to 359 and 49. That means that there were 359 observations belonging to one of the classes, in this case class 1, and 49 belonging to class 2. And finally, we have class equal to class 1. This means that most of the observations in this node belong to class 1. Now, before I forget, as you can see, our tree has 3 levels. This is because at the very beginning, when we create our tree, we set max depth equal to 3. Now, let me show you something cool. We're gonna see how this tree works. So let's say that we have an observation. We're gonna call it test. And it has 6 features, as you can see. And then in these 2 lines of code, we're gonna ask our tree to predict which class this observation belonged to and what's the probability of belonging to that class. So what's going to happen is that our observation will start at the root node, and the tree will ask the question, is feature 4 less or equals than 0.35? In our case, yes it is, so it will move towards the left. Then we ask the question, is feature 4 less or equal than minus 0.4? The answer is no. So then we move vertically down. And then the tree asks the question, is feature 1 less or equal than 1.73? In our case, that's true. So then it will move towards the left. Therefore, our tree will predict that our observation belongs to class 1 with a probability of 66 divided by 66 plus 32. Let's check. So, indeed, belonging to the first class, which in our case is 0, with a probability of 0.66347. Let's see if that is correct. So we have 66 divided by 66 plus 32. Pretty cool, right? All right. Finally, we're going to talk about gene impurity and how to calculate it. As I mentioned before, gene impurity is a measure of how pure your node is. The closer to 0, the more pure your node will be. And the formula to calculate it can be seen here. So it's 1 minus the sums of the probabilities squares, the piece of i's. And these piece of i's are just the probability of obtaining one observation belonging to one of the classes at random. Imagine that you have a jar with gummy bears, let's say blue and red, and then this piece of I will be the probability of picking a red one or a blue one at random. Now, here I wrote a function to calculate the gene impurity when you have only two classes. So it takes as an input two numbers, A and B, then calculates piece of A, then calculates piece of B, and then the gene impurity with the formula that I show you up here, and returns the gene impurity. So imagine that you have a jar with blue and red gummy bears. You have 9 blue, 1 red, and you want to know the gene impurity of your sample. Well, in this case, it will be 0.18. Now, going back to our tree, let me show you how the gene impurities are calculated. For example, let's take a look at this node right here. We have value equal to 293,10. Therefore, we're going to put those two numbers in our gene impurity formula. So it's 293,10. And we should get gene equals to 0.06 or at least very close to that. Let's take a look. Pretty cool, right? Alright guys, I hope you like this video. I'll talk to you soon. Bye bye.